Welcome to Future Doctor NEET Academy for the problem solving session in NEET Physics. Topic chosen today is from Chapter 7, Alternating Current. And today is not problem solving session, problem questionnaire session. That is, 7 questions will be sprayed in this session, and in next session, we will solve the solution for this question. Let's see only the question in this session. Question number 1. The variation of EMF with time for 4 types of generators are shown in the figures. Which among them can be called AC? Option A, that's a 4 different waveform is given. A waveform, B waveform, C waveform, D waveform. That is, here we should know the idea about the actual AC, alternating current, that range. By knowing the nature of AC, you are able to find the waveform from the option. Let's move to question number 2. A circuit when connected to an AC source of 12 volt gives a current of 0.2 ampere. The same circuit when connected to a DC source of 12 volt gives a current of 0.4 ampere. The circuit is dash. A, series LR. What is LR? Inductance and resistance. Series RC, that is a B option. RC is resistance and capacitance. C option, series LC. D option, series LCR. That is, you should know the formula for LCR circuit. There is a series means LCR series circuit. By knowing that idea, by knowing the formula, you are able to solve this solution. Let's move to question number. A small signal voltage V of t equal to V naught sine omega t is applied across an ideal capacitor C. Then A, option A, over a full cycle, the capacitor C does not consume any energy from the voltage source. B option, current I of t is in phase with voltage V of t. C option, current I of t leads voltage V of t by 180 degree. D option, current I of t lags voltage V of t by 90 degree. Here you should know the relationship between the capacitance when it is connected with AC source. That current and voltage value, that graph you should know, which is lagging, which is leading. Based on the idea, you are able to solve this question. Let's move to question number 4. A 100 ohm resistance and a capacitor of 100 ohm reactance are connected in series across a 220 volt source. When the capacitor is 50% charged, the peak value of the displacement current is dash. A option 2.2 ampere. B option 11 ampere. C option 4.4 ampere. D option 11 root 2 ampere. Here you should know the relation between the resistance, capacitive reactance, and the current with respect to charge. There is a capacitance of a capacitor. By knowing the idea, you will solve this solution. Let's move to question number 5. A coil of self-inductance L is connected in series with a bulb B and an AC source. Brightness of the bulb decreased when? Option A, frequency of the AC source is decreased. B option, number of turns in the coil is reduced. C option, a capacitance of reactance Xc equal to XL is included in the same circuit. D option, an iron rod is inserted in the coil. Here what you want to find, that is brightness of the bulb. So by knowing the current value with respect to self-inductance coil, you will find the solution for this. Let's move to question number 6. In an AC circuit, an alternating voltage E equal to 200 root 2 sine 100 t volt is connected to a capacitor of capacity 1 microfarad. The RMS value of the current in the circuit is dash. A option 100 milliampere. B option 200 milliampere. C option 20 milliampere. D option 10 milliampere. You should know the relation between RMS value of the current in terms of capacitor, in terms of EMF. By knowing the formula, you will solve this question. Let's move to question number 7. An AC voltage is applied to a resistance R and an inductor L in series. If R and the inductive reactance are both equal to 3 ohm, the phase difference between the applied voltage and the current in the circuit is dash. A option pi by 4, B option pi by 2, C option 0, D option pi by 6. That is, by knowing the relationship between phase difference in the L and R series circuit. By knowing the formula, you can solve these. Thank you, students. In next session, we will see how to solve the solution for this question.